All right. Oh, I have my notes from our last video up there. Okay. So this is the first video that is associated with the PowerPoint slideshow equilibrium part 4. This is the first one. And we've been talking about rice tables. The previous 2 videos were about setting up rice tables. The first one was if you're given only initial amount of reactant. The second one was if you're given only initial amount of product. What happens if you're given some of both? This is probably the toughest problem that we see. It's a doozy. So what happens? How do we solve a problem if we're given both product and reaction? We can't say, oh, one side is 0, so we always add to that side. You can't subtract from 0. So here's where we have to do an additional step. So the first step is set up the K expression and plug in the values given. If any of your reactants or products are starting with 0, you don't have to do this. If you have 3 products and you're given initial amounts for 2, but not the third unless it's a solid or a liquid, right? If it's a solid or a liquid, we don't need that information. But if any side of your reaction has 0 to start with, again, except solid and liquid, then you can go ahead and refer back to those previous 2 examples. But if you're given some amount of everything except solid and liquid, then we have to do this step. We're going to find Q, which is what you get when you plug in the numbers to a K expression, and you're going to get a value. And here's the trick, a little bit of a trick one of my students taught me. It has to be in alphabetical order though. So if K equals Q, we're at equilibrium. Okay, that one we should be familiar with. If you plug in the numbers and you get the numerical value of K, done, you're at equilibrium. What if K is greater than Q? Remember, this is products over reactants. So if Q is too small, that it means it needs to make more product to reestablish that balance. So my student taught me if you write this in alphabetical order, the greater than sign can become an arrow, and it's called shift right. That means we add to the product side and minus from the reactant side on your change line. What about if K is less than Q? That means Q is too big. You need to take away from the product side and add to the reactant side. Again, if you put this in alphabetical order, you can make the less than symbol an arrow, and it tells you that's the direction it's going. We call it shift left to reestablish equilibrium. We call that Le Chatelier's principle. We'll talk a little bit more about. And this means that we're adding on the reactant side and subtracting on the product side. Okay, so let's work through an example. Okay, so we have 2 NaOCl gas forming 2 moles of NO gas and 1 mole of chlorine gas. And I am given an initial amount of, oh, you know what? I have a typo on here. If I have initial change equilibrium, I have 1 mole in 1 liter, 1 mole in 1 liter, which is 1 molar. This also has 1 mole in 1 liter, which is 1 molar. And actually this one is supposed to be 1 molar as well. Okay, now I don't know which side is my negative and which side is my positive. So that means I have to do that first step. If I have something of everything, I have to set up. And I am given K. It is 1.6 times 10 to the minus 5. That's K given in the problem. So now I'm going to set up my K expression, NO squared times chlorine, and then on the denominator, NaCl, entire quantity squared. Okay, so I can put these values in. This one is pretty straightforward. 1 squared times 1 divided by 1 squared is 1. That's pretty nice. Okay. All right, so this is Q, and it does not equal this value of K. So now we have to determine, is K greater than or less than Q? So this is Q. This is the number you get when you plug in any random amount. K is less than Q. So that means we shift left, which means we're going to, and you can refer up here, we're going to add plus coefficient X to my reactant side minus coefficient X minus an understood 1 coefficient X on my product side. So that's how we determine which side has a negative and which side has a positive when you have something of everyone. Okay, so my last line is just combining those two. So that's 1 plus 2x. This is 1 minus 2x and 1 minus x. Now we're not going to solve for this one. We're just setting up this one. The math is going to be kind of insane. So we're just going to set this one up. Okay, so now that I have my equilibrium expressions or values, now I want to set up my new K expression, only I'm going to plug those equilibrium value amounts into the K expression. And don't worry, I'm not going to give you a problem that is this mathematically rigorous for your exam. This is one just, or any homework problem, this is one just to set up. You can tell because you have a cube, you would have a cube here, right? X to the third, and that's not covered in college algebra, which is our prereq. So this is how you set up to solve when you have when you have some amount of every component of the reaction. Some reactant, some product. Now, I want to stop here, but before I do, I'm going to have a video where we have a problem that has crazy exponents and coefficients, but we're given one of the equilibrium concentrations. If we're given any of these, then we can solve this problem in a cinch. So this is how you set up the problem when you have some amount of reactant. Every reactant and every product has some amount.